Hi, I'm Yong Sheng. I'm the group leader of Group 10. For your information, our group IDP project is IoT Smart Greenhouse. So now I want to present about what I'm doing in this project. As a leader, my job is to lead the group and ensure every task is complete on time and do the planning to our project. Besides, we need to design an IoT system that used to connect with the ESP, online server, and Android applications. So all the connection is connect together. So to communicate with each other, we need to create another one is MySQLi database that used to store all the sensors data and the sensors value. Besides, PHP coding is used to request the data, and the connections between the MySQLi database is used PHP coding. So all the communication is sending and received by PHP coding. To interact with the user, we need to create an application to display the sensors value, historical diagram, and control the output of the greenhouse. For example, control the fans, the water pump, the fertilizer, and the lighting system. So the application will show all the information of the greenhouse and the current situations of the greenhouse. Then we need to create another function which is notification functions of the Android applications that used to alert the user when have the emergency case happen in the greenhouse. So that's all for me. Thank you.
Assalamualaikum. My name is Muhammad Nazirul Mufin bin Mokhtar. My IDP project is IoT based smart greenhouse. Okay. My task in this project is to build the prototype of smart greenhouse and soldering the component. This is the prototype of IDP projects. Okay. The component that we use to build the base of the smart greenhouse is the plywood we use. We use Perspex, the body of the smart greenhouse. Sensor that we use is temperature and humidity sensor. The function is to check the temperature and humidity in smart greenhouse. This is a cycle sensor, LDR sensor, can be used to sense the light. This is moisture sensor to check the moisture of soil in the smart greenhouse. We will use two moisture sensor. This is PIR sensor. We use PIR sensor because to sense the presence of humans and animals. This is Arduino Uno. The fans we use to cooling down the temperature that inside the smart greenhouse. This is ESP8266 to transfer data from sensor to application. This is UV light. Okay, this is our prototype. This is UV light. All the sensor we put on the upper of the prototype. Okay. This is a water pump. Water pump will pump the water through the upper of the prototype. Okay, this is the prototype. Okay, that's all.
Hello everyone, I'm Lee Junwei, which from group number 10. So I'm here, would like to present what is my job scopes and taking part in this project. So before we build the prototype, we need to design. So I'm taking the part to design the concept design. So the design concept idea is from the survey form which the people that fill in what is their needed. And the idea is also from my group member how to decorate and how to make the better ways to build the prototype. So after that, I submit few concept design. So we will choose together and choose the best one concept design. So choose the best concept design. After that, we only to build it. To build the concept design, we have few types of material such as wood plug, wood board, and acrylic, and also the water powder. For a hardware part, So I'm using to build the watering systems and fertilization with using the bottle, which means 5.5 liter bottle, and then using the wood plug to build a box shapes to do as a structure to support the acrylic and to support the sensor and lamp inside the greenhouse. So after building the greenhouse, all the things will built on the wood box. So the wood box can support all the structures, including the water tanks and sensor together. And sometimes I will making the soldering also to build the sensor in the greenhouse. That's my part. Thank you very much.
Hi everyone, my name is Ali Hamid Al Khader and my group is 10 and our title is the IoT based on smart greenhouse, and my contribution toward this project to interface the sensors with the Arduino. So which they are the sensors we have around four sensors: temperature and humidity sensor, BIR, LDR, and soil meter sensor. And here I'm gonna describe each sensor briefly. We will start with DHT11, which is the humidity and temperature sensors that can detect or measure the temperature and humidity around the greenhouse and send the data to the Arduino. The second sensor is PIR sensor, which is the passive infrared sensor to detect if there is any motion around or in the greenhouse and send it to the Arduino. The third sensor is soil meter sensors that can measure and detect the wetness in the soil and send it to the Arduino. The last sensor is LDR to detect the lights inside the greenhouse and send it to the Arduino. So all the data that's collected inside the Arduino will be sent to upload to the cloud by ESP8266 that can transfer the data from the Arduino to the cloud, uploaded to the cloud. And this is all my my part I have done in this projects, and the rest of the job my friends they handle it. And thank you so much.
Sir, my name is Purniswari Shanmugam. I'm from Mechatronic Engineering, final year. My team number is 10, IoT-based smart greenhouse. In this project, I would like to present about the pumps, the water pumps. There is two pumps. One is water pump and one is fertilizer. Our greenhouse using these two pumps to make sure the plant get the water easily, and correctly on time. For the water pump, we place the tube on the upside of the greenhouse so that this one will work like a sprinkler, but not actually sprinkler. So it will pour the water to the plant. And then why we use the water pump and fertilizer? Because we need to water the plant correctly, right? So, and the fertilizer is to make sure that we will be fertilized automatically, so that there won't be any manpower. Fertilizer, we can use the biofertilizer, which is very friendly to the environment and also can save the cost. And then I would like to talk about the plant which we can plant in our greenhouse. This greenhouse is don't have the aircon, so you can plant like vegetables like chili, onion, sawi, cucumber, and like the plant can survive, all the plant those can survive in our normal temperature, the outdoor temperature. So also this one, we also can control the temperature and humidity because we have the controlling system inside. So whenever the day goes very hot, we can water it easily from the application, and also we can decrease the temperature increase the temperature whenever the day is too cold. And I think that's all for my presentation.
So this is our prototype of the greenhouse. The size is 50 cm times 35 cm, so it can fit more than 2 plants. And then this is a water tank and a fertilizer tank. And then this is the data that when the program is running. So now the ESP is running and the program is running. Now I want to show you the applications here. So now everything is off. When the light is on, turn on. Okay, you can see that the light turn on. Okay, off. Okay, off. And then now turn on the fertilizer. Okay, because of the connections of the PF2 is too weak, so the motion will delay. So we will wait until the connections stable back. Now it's searching the connections. After a few seconds, the fertilizer is turned on. You can see the water is running, and then inside there the water is running now. It's running very slowly because this is the fertilizer. So now turning on the watering system.